Welcome to the Thanksgiving special edition of How Things Are Made by Physics. First, I would like to thank my parents who brought me to this physical world. And I would like to thank my physics professors who teach me so much of exciting physics. And I would like to thank my best friend of high school, HS, who teaches me about love and being loved, non-physically. Last but not least, thanks but no thanks, my roommate Andrew, who decorated the room so beautifully that forced me to sneak into his room to make this physics video while he and Megan are physically in Boston for the holiday. Last time, we showed that boiling required input of heat. Today, we want to do a reverse experiment, frozen. Of course, this requires the extraction of heat. Here are 2 cups of water. One contains cold water. The other contains hot water. I will put some membrane on the top to prevent them evaporate. These are all you need to repeat the experiment. I'm going to put them in the fridge. Question: which one do you think will become frozen first? The cold water or the hot water? Normally, people think since we need to extract heat to make water frozen, must be the cold water. Okay. In the fridge, I already prepared 2 cups of such cups. They have been in the fridge for 2 hours. Let's take a look. Can you see? Can you see that the hot cup is almost frozen, while the cold cup is still water? Holy moly! How come the hot water frozen faster? Let's look at the schematic picture. Last time, we mentioned that the molecular structural differences between water and a gas. Can you think of another structural difference between hot water and cold water? Actually, there is. In hot water, water molecules are more energetic, so they are more free to move around, while in cold water, molecules are more stagnant. But this itself is not enough to explain the mystery. The second ingredient is that when the water in the cup that starts to freeze, it creates an ice shell layer. This ice layer acts like a heat insulator. It can slow down the heat extraction process, make it more difficult for heat in the center of the cup to get out. For hot water, water molecules are moving around, so it's not easy to form ice shell. It will eventually be formed, and they will form a shell with a large bulk of water at a later stage. While for cold water, ice shells are formed at a very early stage. You may ask another question: if shell is solid ice, should solid be denser than water? So solid ice shall sink down to the bottom of the cup, so shell will not work like a shell. Actually, it's just the opposite. For ice near the freezing temperature, it is lighter than water. That is, it will flow on the water. It's not sink to the bottom. When you travel to the Niagara Falls in winter, when temperature is like -20 Fahrenheit, you see the whole river is frozen. Do you wonder What happened to the fish? Do they become frozen fish? No, thanks to the ice layer, the fish are cold but not frozen. This experiment demonstrates another reason why global warming is dangerous, because it rises ocean temperature. This will be like the hot water cup. So in the winter, a thicker layer will be formed in the ocean. So for many fish that don't live in the ultra deep ocean may not survive in the winter. Thank you for watching. In the next 3 episodes of How Things Are Made by Physics, I will take you outside. We will talk about physics of mechanics, which we all learn in high school. In the next video, I will be on my skateboard. Thank you for watching. See you next time.